12.1 talks about sequences and summation notation. We start with a sequence. What a sequence is a list of numbers. Those numbers have a specific order that you must pay attention to. The domain of those subscripts would be the natural numbers 1, 2, 3, 4 all the way up. A sub 1 is the first term on the list, A sub 2 is the second term on the list. If you can find this term, A sub n, that's an important term because that term, if it can be found, it generates the entire sequence. Something that you should pay attention that saves you a lot of work. If we're talking about natural numbers, if I tell you I am at the natural number n, the number after that is one more, since fractions are not allowed and decimals are not allowed, and the number before is n minus 1. So anytime we're talking about a term, it would be very helpful for you to think of a sub n plus 1 is the next term and a sub n minus 1 is the previous term. Kind of like saying this is 7, automatically that's an 8 and that's a 6. A sub 7, if that's the term we're at right now, a sub 8 is the next term and a sub 6 would be the term before. Thinking in terms of those will save you a lot of work on the long run. So we start off fairly simple, straightforward. Given the general term, give me a few terms. The nth term of a sequence is given. List the first 3 terms and the 50th term. So if I want to find the first term, you notice whatever this is, this is. That's kind of like saying y equal 3x minus 2 if you want to think about it. And when we put 1, we're saying if x equal 1, 3 times 1 is 3. So that is 3 times 1 minus 2. And I'm going to break the rule here. Write that as a 1. A sub 2 would be 3 times 2. Well, 3 times 2 minus 2, that would be a 4. Again, this is where I'm breaking the rule. I'm going sideways instead of vertical. But you know what? No need to do that. We've been doing this all along. Might as well wrap it up now. And what is that going to take? With just a bit more spacing, we have plenty of space. A sub 3 is going to be 3 times 3 minus 2, which is 7. And a sub 50, the 50th term on this list, is 3 times 50 minus 2. That would be 150 minus 2. That would be 148. So what's so important about having a general term? You could find any term you like on this list. And I could work backwards. If you give me a term, I could replace this by it and tell you where does it fall on the list. Basically, which term is it? Same deal on part B. I want to find the first 3 terms. The first term, throw a 1 in there. That is simply 3. A sub 2, throw a 2 in there. That's radical 2 plus 2. Well, that's what it is. A sub 3, radical 3 plus 2. Well, that's what it is. And a sub 50, that would be radical 50 plus 2. If you simplify, that's 25 times 2. That's 5 radical 2 plus 2. There it is. If I go for the next term, part C, next sequence I should say, the first term on the list is 1 squared over 1 plus 1. That is 1/2. A sub 2 would be 2 squared, which is a 4 over 2 plus 1. That is 4/3. A sub 3 would be 9 over 10, and 9 over 4, 3 plus 1, right? And the 50th term is 50 squared, that's 2500, over 50 plus 1, which is 51. So the beauty of the general term, if you could find it, it could generate any term you like. And again, I'm going to work backwards. I could if I want. If you tell me a term, I could replace a sub n by it. set it equal and solve for n, and that will tell me where it falls on the list. And if the number doesn't fall on the list, then n would not be a whole number. It will be a fraction. Here, a sub n is 2. So this list consists of the following. The first term is a 2, the second is a 2. This is a constant. This never changes, never terminates. So a sub 1 is a 2, a sub 2 is a 2, a sub 3 is a 2, and a sub 50 is also a 2. You got to be careful with those because they do come up a lot. And if I get to the next problem, we're dealing with recursive sequences. What recursive sequences are, it is a list in which terms are determined by an operation on previous terms. So unlike the previous set of general terms, here the general terms, you notice, this is the general term. To find any term, take the term before it and divide it by 3. If I want to find the first 4 terms of the sequence, well, the first term is a 27. You notice here they have to give you one term at least. Second term, take the previous term, which is 27 divided by 3, that's a 9. The third term, take the second term and divide it by 3, that is 9 divided by 3, that's a 3. And if I can guess the third term, that will be fourth term, that will be really good. Guessing that's a 1. Do you see here, to find the 50th term, we will have an issue. Because if I say find a sub 50, well, you need to know what the 49th term is and divide it by 2. So unlike the previous general terms, it doesn't work like that here. Well, here again, to find any term, take 2 divided by the previous term. The first term is a 2. The second term, take 2 divided by a sub 1. That is 2 divided, the previous term is a sub 3, take 2 and divide it by the previous term. That is 2 over 1, which is 2. To find a sub 4, take the 2 divided by the previous term. The previous term is 2. That's a 1. And there it is. This list consists of the numbers 2, 1, 2, 1, 2, 1 all the way down. Oops, I didn't give this a letter. I meant to give this the letter C. Okay. And here you notice it says to find any term, take the term before that and add it to the term before that even. So here they give us A2 and A3, well, A1 and A2. The first term is a 1, the second term is a 2. To find A3, take the one before and add it to the one before that. So 1 plus 2, that's a 3. A sub 4, take the one before 4, add it to the one before 3. That is 3 plus 2, which is a 5. So add those two, that's an 8. Add those two, that's an 11. 19. These are the famous Fibonacci numbers. Find the nth term of each geometric sequence. Well, if each sequence, I'm sorry, I was thinking of something else. So, I look at what's changing. I notice those are, the top is always a 1, but it's 1 time negative, 1 time positive. So this is how you do alternating. I'll deal with whether I got it right or not in a minute. Over. I notice the bottom is 2. I'm trying to find a pattern. 2, 4, 8, 16, 32. So it seems I'm multiplying by 2, right? it seems I'm multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. I thought I was adding first. 4 plus 2 is 2 plus 2 is 4. 4 plus 2 is not 8, so you're not adding. You're multiplying by 2. And 8 times 2 is 16. And 16 times 2 is 38. So I could do it that way, or I could think of it this way as well. I could say, well, look, that is 2 to the 1, that's 2 squared, that's 2 cubed, that's 2 to the 4th, that's 2 to the 5th. So a sub 1, a sub 2, a sub 3, a sub 4, a sub... Do you notice they all have a 2? If this is 1, 2 to the 1. If this is 2, 2 squared. If this is 3, 3 squared. Now, I have to see if I got the alternating part. For example, a sub 3. Negative 1 to the 3rd power is negative 1 over 2 cubed. Is the third term on the list negative 1/8? The third term on the list is 1/8, but it's not negative. If that happens, either add a 1 to that or subtract 1, meaning shift the negative to the back or to the front, and since it's alternating, that does the trick. So here we're kind of guessing using trial and error to figure out the general term. In the next 2 sections, we'll have specific formulas, and you don't have to guess those. You could predict exactly what those are by using specific formulas for what's known as an arithmetic sequence and a geometric sequence. Here, if I look at this, this is a sub 1, a sub 2, a sub 3, a sub 4. I notice that if this is 1, this is 3, 2 more. If this is 2, this is 4, 2 more. If this is 3, this is 5, 2 more. It seems whatever this is, that denominator is 2 more than that. So now if I let n equal 1, I get the 3. N equal 2, I get the 4. And it seems the top is 1 more than the bottom. Do you see that? Whatever the bottom is, the top is 1 more. If I take n plus 2 and add 1 to it, isn't that? And again, we're using trial and error. In the next section, you're going to be able to find those using a specific formula, and you don't have to really guess. I notice this sequence is alternating. This is how we deal with alternating. Except you got to make sure that you get the right positive or negative. Well, if I let n equal 1, or if I let n equal 4, a sub 4, according to this formula, is negative 1 to the 4th, which is 1. But 1, 2, 3, I know the 4th term is negative 1, so either make that power a plus 1 or a minus 1. And now if I want a sub 4, put a 4 in there. 4 plus 1 is a 5. And negative 1 to the 5th power is negative 1. It checks. That's as far as sequences. Now summation. Adding those terms. S sub 1 is the first. S sub 2 is the first 2 terms. S sub 3 is the sum of the first 3. S sub 4 the sum of the first 4. S sub n is the first sum of the first n terms. So, summation notation. This stands for sum. So if I want to take S sub n, the sum of the first n terms, this is where you start. This is where you terminate. And this is always the general term in terms of I. So find the first 4 partial sums and the nth partial term. If I want to find a sub 1, that is 1 over 1 minus 1 over 2. Done deal. That's 1/2. If I want to find a sub 2, that is 1 over 1. Okay, I lied. Forgive me. First 4 partial sums. A sub 1 is 1. Oh, it is. I'm sorry. 1 over 1. Yeah, I was correct. So, S sub 1, I should say. That's what I write. S sub 1 is A sub 1. Well, replace n by 1. Whatever this is, that is. And this is 1 more than that. S sub 2 is A sub 1 plus A sub 2. Well, A sub 1 is 1 over 1 minus 1 half plus a sub 2. And a sub 2 is, put a 2 in there, 1 half minus 1/3. Do you notice those cancel out? And I'm left with 1 minus 1/3, which is 2/3. S sub 3, a sub 1 plus a sub 2 plus a sub 3. That is 1 over 1 minus 1 half plus 1 half minus 1/3 plus a sub 3, 1 over 3 minus 1 over 4. Do you notice those two cancel out and those two cancel out, and I'm left with 1 minus 1/4, which is 3/4. They want us to find the first 4 partial sums and the nth partial sum. Okay, and if I go for S sub 4, I'm going to rearrange this really quick. Okay, I moved that to the bottom. So when I went to find S sub 4, that is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. I'm not talking about shortcuts here. The first term is 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3, a sub 3, 1 over 3 minus 1 over 4, a sub 4, 1 over 4 minus 1 over 5. And I do notice a trend. Those two cancel out. Those two cancel out. Those two cancel out. It seems I'm always left with the very first term minus the last term, and that's 4/5. So when I want to find the general term, a sub n, that is 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5, 3 dots, plus the very last term is you substituting n, which is pretty much what you see. Wouldn't the term before be 1 less and 1 less? And maybe list another term just to convince you of how this pattern behaves. Isn't this 1 less than that and 1 less than that? So S sub n will equal, those two will cancel out, those two will cancel out, those two will cancel out. Isn't this going to cancel with the next parentheses? Here, wouldn't these two cancel out? Wouldn't these two cancel? Oops, that should have been minus 1, right? Cancel out. Wouldn't this cancel with the one before? Doesn't that mean you're going to get the very first term minus the last term? And all over n plus 1, that's n plus 1 minus 1, which is n over n plus 1. This is called telescoping, by the way, something you will need in second semester calculus. Here's another problem. We want to tackle that. Let me check how much more we have to do.